Who are you?
There are some who call me Tim.
What the heck is that?
It's the hammer calculus. It summons the calculus problem number 4 from the year 2012 FRQ.
Wow.
For our question, the function f is defined by f of x equals the square root of 25 minus x squared in the interval -5 to 5. Part A of the question is find the derivative of f of x. To start, I can rewrite f of x in easier terms to take the derivative of. Next, take the derivative. Don't forget the chain rule. Then you can rewrite in this form. Okay, and then just simplify and you get your answer. Ta-da! For part A, both points are awarded for correctly finding the derivative. A common mistake would be forgetting to include the chain rule of the function from the negative x squared inside the square root. Other errors would just include simple algebra errors when manipulating the equation. The key concept of part A is derivatives.
So question B asks you to write the equation for the tangent line on this equation at the point x equals -3. Okay, so the first thing you do in this problem is find f prime of 3 and what that equals. So you just evaluate the equation. And you get 3/4 for the slope. And then you find f of -3 for the original equation. Which is 4. And then from that, you can use the point slope form to find the tangent line. So you put y minus 4 equals 3/4 x plus 3. And you get y equals 3/4 x plus 25/4, which is the answer. Alright, so for part B, you were awarded 1 point for correctly finding f prime of -3, and then 1 point for correctly figuring out the answer. So common mistakes would be incorrectly evaluating f prime of -3, and then also incorrectly evaluating the tangent line equation. The key concept of part B is tangent lines and how to find them.
For part C, we need to find if g is continuous at x equals -3, if g of x is equal to f of x for -5 to -3 and x plus 7 for -3 to 5. So for this part, we're going to use one-sided limits. We need to find the limit as x approaches -3 from the left of g of x, and the limit as x approaches -3 from the right of g of x. And since f of x is to the left of -3, we use f of x for this limit. And for this one, since x plus 7 is to the right, we use x plus 7 for this limit. So up here, we're going to be plugging -3, or well, this is a limit as x approaches -3 from the left of square root of 25 minus x squared, and you just have to plug in -3 into x, so the square root of 25 minus 9, and that gives you square root of 16, which is equal to 4. And down here we do the same thing except with x plus 7. So take the limit as x approaches -3 from the left, or from the right, of x plus 7, plug in -3 plus 7, and that also gets you 4. And since both of the answers were 4, you can see that both of the sides of the equation, or both parts of the equation, are approaching the same number, which means g is continuous at x equals -3. For part C of this problem, 1 point is awarded for considering one-sided limits, and another point is awarded for having your answer with explanation. Common mistakes would include not knowing how to handle a piecewise function or simple algebra errors. Key concepts for part C include limits and piecewise functions.
For part D of this problem, we have to do the integral from 0 to 5, and then x root 25 minus x squared dx. First, we have to use u sub for 25 minus x squared, and integrate that, or derive it, sorry, to find du. Once we have that, we can substitute it in. And then since du is -2x, we need to add -1/2 to balance it out front. And then from there, we know we have, when we integrate it, we have 2 -1/2. And then in order to find the limits for this with the new u, we have to substitute in, with u equals 25 minus x squared, we have to substitute in the original points, so, and that gives you 0, and then sorry, no, it's 0, 25, so from there we can do From this point, we're able to evaluate it. Once we multiply this in, we get which gives, negatives. And then that is your answer. In part D, points were awarded for first doing the antiderivative correctly, and the second was just for the answer. The common mistake some people may have is not putting the negative 1/2 out to balance it, and another common mistake would be not substituting in the original points 0 and 5 in order to find 0 and 25, which are your new bounds. A key concept for part D is U substitution and integration.
On the sample problems, student A scored all 9 points on the FRQ.
For the second sample response, student B earned 6 points. They earned full points on the first two parts of the problem, no points on part C, and only 2 out of 3 points on part D. For part C, the student's work is not sufficient for any points. In part D, the student only earned 1 point for the antiderivative due to a sign error.
Student C got 3 points, 2 points for part A, 1 point for part B, and no points for part C or D. In part A, the student's work is correct, but in part B, the student evaluated f prime incorrectly and used a wrong set of points in order to get the equation of the tangent line. In part C and D, none of the student's work was correct.
This last student, student D, he didn't do very well. I'm sorry. Just look at this. What is he doing?
Y'all mind if I hit that?
My chips are gone. My math is done. I don't know what else to say though.
Wow.